Hello everyone, welcome back in another video. I am Vaibhav. Today date is the 7th of September 2022 and we are going to see thread pool in Java. So all we know what is the function of thread. Thread is a thread is a generated at a time of when we are executing a code. That time each code having their main method. So that particular main method are having when main method get executed. That time they're creating a generating a thread. That thread travels throughout that main method, and each and every function, class, and interface or whatever it presence in that main method that should be executed by the thread. After the complete execution of that main method, that thread should be killed or that thread should be returned. So that is the function of thread. So why we need a thread pool in this case? Previously, we are using a single thread concept. That means when we are requiring a thread, that time we are creating a thread for each purpose. For at each time we are creating a different threads. So previously we are using concept of single thread. That time we are, suppose I am having a class of a job, and there is a one I am creating an object, and I have to perform some operation on that job class. That time I can write as a syntax like job obj is equal to job. That time I have to creating thread and I have to start that thread. That time I am calling the method of start. That time I can directly write as job dot start and parenthesis. That time that thread get start to work. After that we are giving a next command for that thread for a running operation. That time we are write as a job dot run and within the parenthesis. After that time the thread get start to work, and after then assigning work is done by that thread should be killed or that thread should be returned. That is the function of that is the actual working of thread. But at each time we are creating a thread by using a new keyword. That means in our syntax we are say that object job obj is equal to new job. That time we are using a new keyword. That means when we are using a new keyword, that time some memory allocation should be done in a heap memory. That's why it takes some allocate some memory for that particular function. And for the same, for the creating or performing the particular action by the thread, there was work is done. There is some creating some load on CPU and other the system which are depending on the functionality of that code. That's why it's expensive processes. That means it require again and again creating thread. It's very complicated array or very costly processes. That's why for avoiding to create thread again and again for each function, we are Java can launching the function like a thread pool. Thread pool is nothing but we all know in our previous video in strings constant pool. That time we are discussing about the string pool. The string is immutable. We are not able to change that string. When we creating a string by using new keyword, that time one string is stored in heap memory, and one more that same one more string is stored in SCP. That is string constant pool. Where that string constant pool does not have any reference, but still that object is present in that pool. Like that, in our thread pool also there is an one pool which are which are having some specific size of threads. That means we are putting some thread within that pool, and that thread also are non diable, or that thread are not killed. That means there is a particular size we are getting threads for execution, and that after that execution that thread go back into that pool. So for creating thread pools, there are two types. By using two types we are creating a thread pool. Java can providing two ways to creating a thread pool. First one is that by extending a thread class. There is a thread class. By using that thread class we are able to create a thread pool. And another way is for creating a thread pool is that by implementing the runnable interface. By using that runnable interface, we are able to create a thread pool. But in our previously time, we are giving some additional method for running the thread, for starting the thread. We are giving some particular methods for giving some particular data for running and stopping or clean that thread of a particular system. But Java can provide one more additional class, one more additional interface to perform that start, run and stop operation by that thread pool. That interface is executor service interface. That interface can perform the same operation which we are done by giving the method, by using the methods like start, run. That all performance are that all operation can be done by that executor service interface automatically. That means we are not need to implement that method within that pool. For that pool, it execute thread by itself. So basically, we are having some different types of thread pool. We are creating some different types of thread pools. We can see one by one. So first one is that we are you creating that first pool like a new new fixed thread, new fixed thread pool, and parenthesis. Within that parenthesis, suppose there is a yes. So this is nothing but it is the variable. By that s, we are giving some specific size. Suppose I am write as s int s is equal to 50, and I can write again that new fixed thread pool within parenthesis yes. That means I am creating a thread pool of size 50. I am giving a particular size of 50 for that thread pool. When within my code there is any requirement for generating a thread, that time that thread will be put from the thread pool. It perform their work, and after the completion of that work or that task, that thread came back in their thread pool. That means that thread is not killed or that thread is not removed in that method. In previous methods, we are creating or generating a thread. That thread can get, come, start, run, and after the done of their work, that thread should be killed or that thread get killed. That's why we have to create that thread again and again. Due to that, it take more time for performance of for execution, or it take more memory as compared to the pool. That's why we are using a thread pool. Okay, suppose we are having size of 50 in our thread pool. We are having 50 threads, and I have to give performance task for the 100 threads. So that time what happened? So that time that 50 threads which are present in our thread pool can start to perform or start the task as per their sequence of order. That means as per their given sequence, that 50 thread gets started their task. Well, after they completing their task one by one or as per their task range, that thread get written into thread pool, the thread pool, and that returned thread can start their next task. That means as per their task, first 15 thread can perform the first 15 tasks, and after the completion of that task, as per their completion of task, the remaining thread will be executing that task which are in queue. We are giving a task in form of queues. That means we are giving continuous tasks. They are stored in form of queue. It will be executed or it will be performing their task as per their sequence of coming. But suppose if that memory should be get full, then we have to create one more additional thread pool. For that concept, we are creating a one more thread pool. After that next thread pool is that uh, huh? For we are creating a cached thread pool for that case. Suppose that thread pool having completed by the size, but we are still require creating more thread for operation. That time we are creating again one more thread pool. For support that thread pool we are create like as new cached thread pool. New cached thread pool. That cached thread pool is nothing but same as a thread pool. When our previous thread pool get busy continuously, and the again requirement of thread, that time we are using that our new cached thread pool. After that, the next type for the thread pool, next type of thread generation is single thread execution. As we seen, as we discussed before some time, that is the actual single thread. We are creating a single thread by using new keyword, and that after the performance of their thread, that thread will be eliminated. That is the function of our thread pool. So there is some advantages and disadvantages of thread pool. Let's we see. So major advantage of thread pool is that when we are using a thread pool, that time we are not required to create thread again and again. That's why the performance of execution of our code or execution of code, it should be increased, or performance should be increased, and memory allocation should be within a limit. That means there is a not requirement of again and again allocating a memory for each new thread. We are allocating a memory for a particular that 50 threads, and after that particular 50 threads, we are performing a operation on that 50 threads one by one. That is the major advantage. But there is some lags, or some loopholes in the thread pool is that like that. The first loop is that thread can be self-locked. That means, suppose there is some condition. In that condition, there is a lock-in situation is there. That means we are passing any thread for the performing any task. That time again one more task is there. That tasks are done as per their sequential order. But there is one more condition is that suppose thread A have to go into the thread B, but in a way of thread A there is a obstacle of thread B. That's why that is in lock-in position. That means there is work with that task should be locked, because interrupting thread between them. That's why there is a chance to lock up the thread. That means there is a chance of lack of thread. Another disadvantage is that there is a chance of thread leakage. Thread leakage means, suppose, as we seen in our previous video, there is a try catch exception in multi-threading concept. There is an exception is there. So for avoiding the exception, we are using a try catch block. But thread pool does not support or does not understand about that try catch. It does not having any idea about that exceptions. That's why if any condition is there, as we seen, there is a one scenario of arithmetical condition, arithmetical calculation. That time we are dividing any number by 0. That means there is a arithmetical exception. That time if any thread is passing for performing their arithmetical calculation, that time that thread is killed there, or that thread is killed, or the, so that time not any catch is available for avoid that exception, or get recover or alive that thread in this case. So that time that thread is actually that thread is actually killed for that matter, and our thread pool does not don't know about that particular exception. That time they continuously giving the new thread for giving that threads from that 50 threads continuously, and the threads are suppose that threads are continuously eliminated or die or that kill that thread. So maybe there is a chance to reduce the size of our thread pool. That is the thread leakage. uh, these are that is the overall about thread pool in Java. Thank you.